Hi guys, welcome to your 10-4 notes, solving radical equations. By the end of the day, you will be able to solve equations containing radicals and identify extraneous solutions. Alright, here's our main idea for the day. You can solve radical equations, that's equations with radicals in them, by squaring each side. After you square each side, you will want to test the solutions, just like we always check our work. So let's jump right in. Just like with any equation, you want to undo what's happening to our variable. So right now we've got the square root of a minus 5 equals negative 2. Well, let's undo what's happening to our variable. It's under square root and there's a minus 5. So first we want to undo that minus 5 by adding 5 to both sides. That gives us the square root of a is equal to 3. Now, to undo this square root, we are going to square both sides. So that gives us that a is equal to 9. That's it. Let's go ahead and check our work. Here we go. So we look back at our original equation, and our original equation said the square root of a minus 5 equals negative 2. So instead of a, let's go ahead and plug in our 9 in there. The square root of 9 minus 5 is negative 2. Well, let's check. The square root of 9 is 3, and 3 minus 5 is in fact negative 2. So yes, that works. We did it. Sweet. So again, we undo what's happening to our variable, so we get a radical expression all by itself. We squared it, and we found our answer. Let's do another one. Now in this one, we actually have two square roots. We have two radicals. So the first thing we want to do is we want to square both sides, and that will solve, or rather, that won't solve the issue, but that'll get us one step further into solving. So here, our square roots will undo each other. Squares, and the square roots are gone. Squares, square roots are gone, giving us 7b minus 4 equals 5b plus 10. And now we can treat it like a normal equation. We're trying to solve for b. So I'm going to get all my b's on one side. So we have 2b, and then on the one side, I'm going to get all my numbers on the other side. 2b equals 14. Now, again, we're trying to get b all by itself. So to undo the 2 times, we'll divide by 2. That gives us that b equals 7. Now again, let's check our work. I'm going to plug it back into the original equation. So we have the square root of 7b minus 4. I made my square root way too big. There we go. Is equal to 5b plus 10, that whole square root. And this time instead of b, we'll replace those with 7. So if we think that b in fact is equal to 7, we can replace b from our original equation with 7 and see if it's true. On the side, this gives us 49 minus 4, all under a square root. On the side, 35 plus 10, all under a square root. 49 minus 4 is 45. 35 plus 10 is 45. And yes, the square root of 45 is equal to the square root of 45. So that's right. So far, so good. We are solving radical expressions by squaring to get rid of the square roots. Cool. So, Ms. Van Dyke, when are we going to use this in real life? So glad you asked. Well, let's say you have a pendulum of a clock. So, you know, a clock looks like this, and then it's got the little hands on it. But this guy, this is a big fancy clock, right, that stands in your living room or in your grandparents' living room or something. You got this big old clock. And in it, you've got this big old pendulum that hangs down like this. And the pendulum is the thing that like swings back and forth and makes that tick-tock sound, you know? That's what a pendulum is. So it's swinging back and forth, and the time it takes for pendulum to swing is approximated by this whole expression. t equals 2 times the square root of L over 3.3, where L is the length of the pendulum in feet. If the pendulum of clocks completes a full swing in 1 second, which makes sense because it's swinging every second, what's the length of the pendulum? Round to the nearest tenth of a foot. Well, we know the time it takes to complete a swing is 1 second. So if t is time, we're going to plug 1 in for our t. So that gives us that 1 equals 2 times the square root of L over 3.3. Now our question asked us to find the length. It said where L is the length of the pendulum, what is the length of the pendulum? So we're trying to get this L all by itself. Here we go. So my first step is I want to get rid of this 2 times, so I'm going to divide by 2. So on the one side we have 1/2 equals the square root of L divided by 3.3. Now we're still trying to find this L, so we're going to square both sides to get rid of the square root. So if we have a fraction squared, that's the same thing as the numerator squared divided by the denominator squared. And on this side, the square and the square root cancel out. So that leaves us with just L divided by 3.3. Now 1 squared is 1, and 2 squared is 4. So we have 1/4 equals L over 3.3. Now we're almost done. Remember, we're trying to get this L all by itself. So to undo a divide by 3.3, we're going to times by 3.3 on both sides. And that gives us 3.3 divided by 4 equals L. Super. Except that's a gross fraction. And also they asked to round to the nearest tenth of a foot. So we're going to plug that into our calculator real quick. And that comes out to be exactly 0.825. Rounding to the nearest tenth. 0.8, right? Nearest tenth of a foot? Yeah, about 0.8 feet. Cool. Like 4/5 of a foot. So I guess this is a very, very tiny clock. It's not even a foot long. So there you go. Again, we're solving an equation with a radical, with this radical guy right in here. To undo the radical, you gotta square both sides and simplify. That's our key idea. But there's one extra little thing we need to look out for. We need to look for something extra. So when someone is being extra, see, this is the point of the class period where I would stop and I would ask you guys to define, hey, what does it mean for someone to be extra? And you would give me a really good explanation. But I don't really know what it means for someone to be extra, but you know it when you see it, right? But I can tell you that an extraterrestrial, like the movie E.T., the extraterrestrial, that means from outer space, because extra means like outside of, and then terrestrial is Earth, outside of Earth, from outer space. Similarly, for my Spanish speakers, we have extranjero, which just means a foreigner, someone who is from out of the country. So extra, that extra means like it's outside. It's outside of this earth, it's outside of the country, it's extra, we don't need it, right? So in math, we have what's called an extraneous. An extraneous solution is one that does not satisfy the original equation. That is, It's outside of the situation we started with. Now, to find an extraneous solution, we have to check the original equation and see, does it make it true? So when I say satisfy, I mean, does it make it true? And this is why extraneous solutions are why we always substitute our solution into the original equation to check. This is why we check up here. This is why we always check all the time. We always check our answers. So now, more than ever, make sure you check your solution. Checking your solution is the number one way to check for extraneous solutions. Remember, they're extra. They're too much. We don't need them. They're outside of this possibility. Okay, so what we're going to do now is we have 2 more problems, and then we're going to check for extraneous solutions and go on our merry way. So let's start here. Negative c equals the square root of c plus 6. Now I notice right away we've got this square root, so to undo that square root, we'll square both sides. Cool, that's gone on the right side, leaving us with just c plus 6. And then negative c times negative c is c squared. Awesome. Now, how are we going to solve this? Well, get stoked. So exciting. We're going to subtract c and subtract 6 from both sides. This will give us c squared minus c minus 6 equals, well, our c's cancel out and our 6's cancel out, giving us 0. Where have we seen this before? What is this? This is a quadratic equation. Yay! We love them. They're the best. We have a quadratic equation, and how can we solve quadratic equations? Well, we plug them in the quadratic formula, or we graph them, or this one, you guys, this one's going to be really fast to factor, so let's factor it. Again, we're looking for 2 numbers that multiply to negative 6 and add to negative 1. Those numbers are going to be, what did we say? Multiply to negative 6, add to negative 1. So that'll be minus 3 plus 2. So I have c minus 3 and c plus 2 equals 0. To solve this equation, that gives us c minus 3 equals 0. C plus 2 equals 0, so c is negative 2, and c is 3. Cool, we have 2 solutions. But now we need to plug them back into our original equation to check if they both work. Remember that our original equation said negative c equals the square root of c plus 6. So we're going to plug those guys in and check if they work. So is it true that we'll have negative 3, actually, let's do this way. So we're going to get rid of c, and instead of c, we'll make 3. Cool. So that gives us, is it true that negative 3 equals the square root of 9? Well, no, because a square root should be positive. So that's not going to work, because when we take the square root of 9, we say, well, the square root of 9, yeah, it can be negative 3, but it can also be positive 3. And while this one works, this one does not. So that's not going to be true. Yikes. Actually, forget I said that. We're going with just positive. So that's an extra solution. The hint was, it's got a negative right there. That negative is always no good. It's bad news. On the other side, however, we're given that c is negative 2, correct? Yep. Negative 2, negative 2. This gives us a positive 2 equals the square root of 4. Sweetums, we like this positive. So 2 equals 2? Well, yes. Cool. So we're only going to go with that c equals -2. And we're not going to include c equals 3 because that is an extraneous solution. Let's do one more, shall we? Cool. So in our last one, we have 6 minus the square root of 2d equals 10. So let's solve it. Our first step is, and again, in solving our equation, we're trying to get d all by itself, so we're going to undo what's happening to our d. So let's minus 6 from both sides. We have the negative square root of 2d is 4. We'll multiply by -1 on both sides, giving us 2d equals -4. And then we square both sides to undo the square root. So our square root cancels out with our square. 2 times d equals, again, 4 times -4 is 16. Oh, we're almost there. We divide by 2. So d equals 8. Oh, that's so nice, guys. That's even my favorite number. Haha, cool. Okay, now that was so nice. We're going to plug it into our original equation and check that it works. So 6 minus the square root of 2 times d equals 10. Again, we're checking d is 8, d is 8. 6 minus the square root of 2 times 8 equals 10, question mark. Does it, though? So 2 times 8 is 16. 6 minus squared, is it 10? Well, square 16 is 4. Oh. No. That did not work. I'm so sad. Sorry, guys. Yikes. So this has no solution because that was our only solution and it doesn't work. It was extraneous. It was extra. So we say, in conclusion, this has no solution. Because there is no number that will make this true. Again, when you're looking for your square roots, stay positive. That will help you find your extraneous solutions. Extraneous means they don't work. That's why you have to check your solution to make sure that it works. Guys, that is so important. I even put it down here. Remember, very important. It is essential. That means super important, required, necessary. That you check your solutions. Now more than ever. So that you don't include an extraneous solution. Cool. Again, we're going to solve radical equations by squaring on both sides, where you square it. But you also have to check your solutions to make sure they're not extraneous. Hope you enjoy your homework.